Hello, the asset tool is not intended for detailed geometry modeling. For production quality model, it is better to use dedicated modeling software such as Blender or 3ds Max. However, during early state of development, it is often useful to quickly prototype a model using simple primitives before the final mesh is available. We will cover advanced workflow in later tutorial. In this video, we will demonstrate how to prototype a simple articulated vehicle entirely within the asset tool. We begin with a blank scene. We first select the root node and add a rigid body. The rigid body is created with default parameters, mass 1.0 and collision shape set to null. Our prototype will be a simple box tricycle. We change the collision geometry from null to a box and resize it to form the chassis. Once we are satisfied with the dimension, we click Build Visual Mesh. This will generate a visual rendering mesh that matches the collision geometry. Next, we add the wheels one at a time. With the root node selected, we create a child node and we name it left wheel. We repeat the same process by adding a rigid body to this node. Since the node is a child of another rigid body, the tool automatically creates a constraint joint as well. Now we configure the wheel properties. First, we select the appropriate collision shape. The Newton engine provides two specialized collision shapes for tires, the chamfer cylinder and the tire shape. In most cases, the child cylinder should be the preferred option. However, in some situations, the aspect ratio cannot be adjusted to properly match the desired visual geometry. In those cases, the tire shape can be used instead. The tire shape is essentially a unique chamfer cylinder with non-uniform scaling applied, which makes it computationally more expensive to simulate. After setting the wheel dimensions, we oriented it and positioned it relative to the chassis. The tool includes several features that assist with this process, including orthogonal projection modes, preset camera view, and relative or absolute transformation modes. Once the rigid body properties are complete, we move on to configure the constraint properties. Whenever a rigid body is added as a child of another rigid body, the tool automatically creates a default joint between them. For this wheel, we change the joint type to a roller joint. Although a wheel joint could also be used, we will use the roller joint here to demonstrate additional functionalities. A roller joint provides 2 degrees of freedom, a rotation around the primary axis, and a translation along the secondary axis. We then configure the linear axis of the roller joint as a spring damper system, so it behaves like the suspension of a car. Once the first wheel is complete, we move to create the remaining two. Although we could repeat the entire setup process manually, the approach can be time-consuming and error-prone. To simplify the workflow, the tool provides a clone node option. This creates an exact duplicate of the selected node, allowing us to make only minor adjustments and reposition the clone wheel. Once the two rear wheels are built and positioned, we duplicate one more time to make the front wheel. Since the front wheel needs steering capability, we change its joint type to a wheel joint and configure the steering angle. At this point, the basic vehicle skeleton is complete. However, the vehicle still has no locomotion system. To solve this, we add another rigid body node to the chassis to add as the motor. This body can use any shape, but in this example, we use a cylinder. The motor rigid body combines a rotor and the differential. Therefore, it should have 2 degrees of freedom, one for controlling forward and backward motion, while the other handles differential wheel rotation when the vehicle turns. The joint for this is the power double hinge. The main requirement is to ensure that the joint axes are properly aligned. Next, we connect the two rear wheels to the motor using differential joints. For this, we select the first wheel and in the rigid body property panel, enable loop joint mode. Then we select the motor node. We repeat the same operation for the second rear wheel. In the outliner panel, we click the constraint loops node and we change each loop joint from the default to a multi-body differential joint. This is in the property panel on the right. Always make sure the joint axes are properly aligned. Finally, we add helpers and modifiers node. Helper nodes are a common practice in application for procedural visual effect, gameplay, logic, attachment point, etc. For this demo, we created a camera pivot hardpoint and positioned it slightly above the root node. The application will use this node to attach a camera when the player is driving the vehicle. We save the model and we move to the application for testing. In the application, we verify that the model behaves as expected. For example, if the suspension feels too soft, we can reopen the model in the Asset tool and adjust the parameter. Finally, we switch camera view and we drive the vehicle. As we mentioned earlier, building complex articulated objects entirely within the Asset tool can be tedious. These features are primarily intended for prototyping, tweaking, and customizing models rather than full-scale content creation. In the next video, we will demonstrate how to import and prepare a more detailed mesh for use within the Asset tool. Until then, thanks for watching.